Let's start. Number 10. A star is eating itself. Right now, somewhere about 10,000 light years from Earth, a star is consuming its own outer layers, not because it's dying, because it's spinning too fast. Scientists call these objects B-stars, and they're some of the most violent, least talked about objects in the galaxy. These stars rotate so fast that their equators bulge outward like a spinning top about to fly apart. The centrifugal force flings material off the surface and forms a glowing disk of hot gas around the star's middle. It's like watching a figure skater spin until their arms rip off and orbit them. What makes this alarming is how common it is. About 1 in every 5 massive stars in the Milky Way is doing this right now. The disk can extend for millions of miles in every direction. Inside that disk, the ejected material is superheated, temperatures climbing to tens of thousands of degrees. And because these disks scatter X-rays, they're slowly irradiating everything nearby. Scientists have only recently started mapping how many of these exist in our galaxy. The number keeps going up. Every time a new telescope comes online, they find more. There are stars actively shredding themselves apart in every direction, in every corner of the galaxy, and most people have never heard of them. Number 9. 2 galaxies are about to collide, and one of them is ours. This isn't a prediction for the distant future. It's already started. The Andromeda Galaxy is barreling toward the Milky Way at roughly 250,000 miles per hour. That's fast enough to travel from Earth to the Moon in about an hour. Scientists have known about this for years, but what they recently confirmed is something far stranger. This collision was supposed to happen cleanly, 2 spirals merging over billions of years into one elliptical galaxy. But new data from the Gaia Space Telescope revealed that Andromeda is not alone. It's dragging an entire entourage of satellite galaxies with it. The gravitational tug-of-war between these incoming satellites and our own is already pulling on the outer edges of the Milky Way. Stars in our galaxy's outer arms are moving in ways that shouldn't be possible if nothing were affecting them. Something is already pulling on us from the outside. The collision itself won't destroy the solar system. Space is so empty that stars will mostly pass each other by, but the gravitational chaos will reshape both galaxies entirely. Our night sky will never look the same again. The process has already begun. The Milky Way is already deforming, and the thing doing it is still millions of light years away. Number 8. Rogue planets are drifting through our solar system's neighborhood. These are planets with no star, no orbit, no sun. They formed around stars billions of years ago and were ejected by gravitational chaos before they could settle. Now they drift through the galaxy in total darkness, completely invisible until they pass close enough to something bright enough to illuminate them briefly. Scientists recently estimated that the Milky Way contains more rogue planets than stars. The galaxy may be flooded with them. Most are gas giants, roughly Jupiter-sized, cold, and dark, but some are smaller, rocky, potentially Earth-sized. The James Webb Space Telescope has already detected several candidates in nearby star-forming regions. And here's the uncomfortable part. These objects follow no predictable path. They don't orbit anything. They move in straight lines through the galaxy, changed only by whatever gravity they happen to drift past. If one were heading toward our solar system, we wouldn't detect it until it was extremely close. By that point, the gravitational influence would already be measurable. We're not talking about a collision. That's extraordinarily unlikely. But a sufficiently massive rogue planet passing close enough could perturb the orbits of outer solar system objects, sending comets inward, changing trajectories, nudging things that have been stable for billions of years. And right now, we have no system specifically designed to watch for them. Number 7. A pulsar is spinning 700 times per second. That sentence should not be physically possible. A pulsar is the collapsed core of a dead star, a neutron star roughly the size of a city, containing more mass than the sun, compressed into something you could fit inside the loop of a highway interchange. It is made almost entirely of neutrons packed so tightly that matter as we know it no longer exists inside it, and one of them is spinning 716 times every second. That's not an estimate, that's a measured value. In the time it takes you to blink, this object completes roughly 30 full rotations. Its surface is moving at a significant fraction of the speed of light. The centrifugal force at its equator is so extreme that if it spun even slightly faster, the star would fly apart. Scientists call these millisecond pulsars, and the reason they spin this fast is because they've been spun up by stealing material from a companion star, matter falling onto the pulsar and transferring angular momentum like a hand spinning a top for billions of years. But the thing that makes this deeply unsettling is what's happening inside these objects. The pressures in the core of a neutron star are so extreme that neutrons themselves may be breaking down. The matter inside might not be made of any particle we've ever identified. There may be exotic states of matter in the cores of millisecond pulsars that don't exist anywhere else in the observable universe, and those cores are spinning 700 times a second. Whatever is in there, it's moving very fast. Number 6. Something is wrong with the sun's magnetic field, not in a scientists are concerned way, in a this is actively rewriting the textbooks way. Every 11 years, the sun's magnetic poles flip. North becomes south, south becomes north, and the entire magnetic personality of the star resets. Scientists have been tracking this for decades, but in the current solar cycle, cycle 25, the activity has accelerated far beyond projections. Solar flares, coronal mass ejections, sunspot counts, all of them have come in higher and faster than any model predicted. The sun is overperforming. In 2024, Earth was hit by the strongest geomagnetic storm in 2 decades. The aurora was visible from Florida, from Mexico, from places where nobody alive had ever seen it before. That's not beautiful. That's a warning sign. The magnetic field that drives these events is the same one that, if disrupted enough, could take down power grids across entire continents. The 1989 Quebec blackout was caused by a storm far weaker than what we've already experienced this cycle. The sun isn't due to calm down for years, and the current cycle is stronger than predicted. Every projection scientists had was wrong in the same direction. Whatever is driving solar activity right now, it's more powerful than our models account for. Number 5. A galaxy is dying in real time. Scientists are watching a galaxy called D100 being killed. Not by a collision, not by a black hole, by speed, as this spiral galaxy moves through the Perseus cluster, a massive collection of galaxies embedded in superhot gas. The gas it's plowing through strips material directly off its outer arms. The process is called ram pressure stripping. Think of it like holding your hand out a car window. At low speeds, nothing happens. At highway speed, the force is real. D100 is moving fast enough through the intracluster medium that its gas, the raw material stars are made from, is being torn away in a stream stretching nearly 200,000 light-years behind it. That's longer than the entire diameter of the Milky Way. With no gas left, D100 can no longer form new stars. The stars it has will age and die. Nothing will replace them. The galaxy will fade. Scientists are watching this happen, not as ancient light from billions of years ago. This is happening on timescales short enough that detailed structural changes are being tracked across multiple observations. In cosmic terms, this is happening now, and what it demonstrates is that galaxies don't need a dramatic death. Sometimes the universe just slowly takes everything away from them until there's nothing left to work with. Number 4. The Milky Way has a bubble in it. Scientists call it the local bubble. It's a cavity in the interstellar gas surrounding our solar system, a region about 1,000 light-years across, where the gas density is dramatically lower than the galactic average. Our solar system sits inside this bubble, has for millions of years. For most of that time, scientists weren't sure what created it. New research answered that question, and the answer is violence. Between 15 and 14 million years ago, a series of supernovae, massive stellar explosions, detonated in close succession. The shock waves from those explosions blasted the surrounding gas outward, creating the cavity we now call home. The expanding shell of that bubble is still moving, and here's the part that changes things. The shell of the local bubble, as it expands outward, compresses the gas around its edges. Compressed gas forms new stars. When scientists mapped the positions of all the young stars in our galactic neighborhood, stars formed in the last few million years, they found that nearly all of them sit on the surface of the bubble. The supernovae that shaped our region of the galaxy also triggered the formation of most of the young stars around us. The solar system is sitting inside an ancient explosion, one that has been shaping the neighborhood ever since. Number 3. Something is moving through the galaxy faster than it should be. Astronomers have identified stars, called hypervelocity stars, that are moving so fast they've exceeded the escape velocity of the Milky Way. These objects are traveling at millions of miles per hour, fast enough to leave the galaxy entirely. They're not just leaving their home system, they're leaving the galaxy. Most hypervelocity stars are believed to have been flung outward by a close encounter with the supermassive black hole at the galactic center, a gravitational slingshot effect that hurls one star away while capturing another. But recent surveys found something unexpected. Some hypervelocity stars don't appear to come from the galactic center. They're moving in the wrong direction. They come from the outer disk, not the core. Whatever accelerated them, it wasn't Sagittarius A star, our central black hole. The mechanism is unknown. One leading candidate is a different kind of slingshot, a binary star system where one star goes supernova and the explosion sends its companion flying. But the math doesn't fully fit every case. Some of these stars are moving in ways that remain genuinely unexpected. explained. They're crossing the galaxy at speeds our models struggle to account for, and they're already on their way out. Number 2. Strange radio signals are coming from inside our own galaxy. Since 2007, astronomers have been detecting what they call fast radio bursts, FRBs. Each one is an intense burst of radio waves that lasts less than a millisecond. They're so bright that they can be detected from halfway across the observable universe, and for years, they all seem to come from outside the Milky Way, from other galaxies, billions of light years away. Then in 2020, one came from inside the Milky Way itself, from a known magnetar about 30,000 light-years away. Scientists confirmed the source. But here's what they couldn't explain. The burst matched the characteristics of extragalactic FRBs almost exactly. The same profile, the same intensity relative to distance, which means that whatever process produces these bursts in distant galaxies could be magnetars. But the magnetar explanation still doesn't fully close the case. Other FRBs repeat on irregular schedules. Some repeat predictably. Some appear to sweep across frequencies in ways magnetars don't obviously explain. These signals are hitting Earth right now. Radio telescopes pick them up regularly. And every time scientists think they've nailed down the source mechanism, a new burst comes in that doesn't quite fit the model. The universe has been broadcasting something. We just don't know what it's saying yet. Number 1. A nearby star is dimming in ways that haven't been explained. Betelgeuse, one of the brightest stars in the night sky, the red giant marking Orion's shoulder, went through a dramatic dimming event in late 2019 and early 2020. It dropped to about 40% of its normal brightness. For a star that has been a navigational landmark for thousands of years of human history, this was not subtle. Astronomers called it the Great Dimming. Initial theories ranged from a massive surface cold spot to the star preparing to go supernova far ahead of schedule. Follow-up observations from the Hubble Space Telescope revealed a more likely explanation. A massive convective cell on the star's surface expelled a large amount of material. That material cooled and condensed into dust, temporarily blocking the star's light. But, and this is important, the explanation for why that expulsion happened is still not fully settled. And the deeper question is what it tells us about Betelgeuse's overall state. Betelgeuse is already in the late stage of its life. It will explode. The question is when. Most estimates put it somewhere between now and 100,000 years from now, which is a very wide range. The Great Dimming didn't narrow that range significantly. It just confirmed that this star is doing things we haven't seen it do before, on a timescale where we're watching.